Okay, now let's do getting help on a function. So we just saw in the last video that you can use functions like sine and cosine, and there are many others. Suppose you don't know how a function works and you want to figure out how to use it. Let's talk about that. So let's try typing help cos. So that brings this up, and this is the help file, or the help documentation for this. The trig, it's in the base. This function comes already installed. Remember, we said there's the base and there's the contributed. So it's in the base, so you don't have to. It comes with the basic R package. And description: these functions give the obvious trigonometric functions. They respectively compute cosine, sine, tangent, arctangent, blah, blah, blah. And here's how you use them. So I guess this one takes two arguments. Not sure what it means actually. Arguments x and y should be numeric or complex vectors. So they don't just have to be numbers, as we saw. They can be vectors, right? Details: the arctangent of has 2. Returns the angle between the x-axis and the vector from the origin xy. So this one, I don't know, you put in the vector xy, but you have to put it in this way, and you get an angle. So it's the angle. Well, anyway, angles are in radians, not degrees. i.e. a right angle is pi over 2. All except arctan are internal generic primitive functions. Methods can be defined for them individually or via the math group generic. For the inverse trigonometric functions, branch cuts are defined as in a Brahman rule. I don't know. Branch cuts, that's just a mathematical term, so we won't worry about that. Some more details here about these specific functions. All except these are S4 generic functions. Methods can be defined for them individually. Okay, and here are some references. Okay, let's try a different function. Let's try mean of, what was that? P. Up here we had P, right? Somewhere, P. By the way, mean of P. So that's the mean of these this vector, or the mean of this list of numbers. So it's 12.5. It's 12.5, right? The middle of this is 12.5. So, this is another function. We could do the help. We could do this help mean. We get this, and now this mean, we just put in a vector x. But we didn't do anything like this. I didn't say mean, I just said mean p, right? Trim equals 0, and so on. So these are the so-called arguments for this function. So this first one is an R object. Currently there are methods for numeric logical vectors and date, time. I can't imagine how you could do a logical vector. But anyway, for data frames for all the whose columns have a method. Okay, complex trim, the fraction 0 to 0.5 of observations to be trimmed from each end of x before the mean is computed. So this is just something that we don't have to worry about always, but you might want to do something like this. So if you go back to the here, if you suppose you just wanted the mean from 11, 12, 13, 14, you didn't want to use the last, this one, the 10, and the 15. You wanted to throw those out before you calculated the mean. Maybe, the largest one is going to be really too large, so you don't want to include that, or the smallest one is going to be really too small, so you don't want to include that for some reason. So you can trim some percentage of the observations. So we might do that. So anyway, that's one of the arguments. And NARM, a logical value indicating whether NA values should be stripped before the computation proceeds. So NA, I believe, stands for not available. So sometimes when you do a calculation, some of the data won't be available, or and if you put that into this mean function, you might have problems because it gets confused if some of the values are so-called NA. So it might say you have this option to take those out first before computing the mean. So that's what this does. In this case, you'd say don't do that, but if this was true, you'd say do that. Anyway, so these are called the arguments. Okay? So let's go back to here and try. We did help, but if you just want to know what the arguments are, you can type this. You could do it you can find the arguments just by typing help, but you could do this also. Maybe. Okay, actually, it's just saying basically that you have to put in x, and x has to come first. But it's really not telling us the other one, so maybe I was a little bit wrong about that. Let's try another function called SD, the standard deviation. Let's try that one, args SD. And it says you need this one and this one. So actually, okay, let's, I'm not so sure about this args, what this args gives us. The null we can usually ignore, supposedly. That's not so useful, is it? Okay, there's another thing, and sometimes they'll give examples of how to use these, so you can do that. You can try example and mean. Let's see what happens there. So it says, where does it start here? So here we have x is, I guess this is that we're in the mean example. And then x, so this is just what we call the prompt, right? Before we just had this arrow, now we have this mean and the arrow, and that's just a prompt. Now, what we're doing here is we're taking x and assigning it from 0 to 10, so that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma 50, right? And then we assign xm, the value, the mean of that. So what's the mean of this? Remember, x is a vector, so what's the mean of this? So because we throw in this 50 at the end, the mean is going to be kind of distorted a little bit. So anyway, and then we're creating a vector, which is the mean, comma, the mean of x, and we're going to trim 10%. So now we're going to probably get rid of this 50. I don't know if it means trim means both sides or just one side, actually. Maybe we can tell. Anyway, I'm not sure. You have to play around with it, maybe. So anyway, the mean for the first one was 8.75. That's because we threw the 50 in there. So that kind of distorted or blew up the mean. Whereas without that 50, it's between 0 and 5. I think they took out the 0 also, so that we get 5.5, because the mean from 1 to 10 is 5.5, not the mean from 0 to 10. I don't think the mean from 0 to 10 is 5.5, so I think it trims both sides. And here, now this last one is really confusing, because you might say, what does this mean? USA arrests or US arrests. But I think that must be like what is that? Let's see if this, let's try that. Let me just type this, US ARRESTS. So this is some kind of predefined data. So it's kind of nice to have it, but you would never know that it was there. So it means all this stuff here. So US arrest is already some data that you can sort of use and play around with and stuff like that. And it's in a variable called US arrest. And that's, what do we call it? It's already there. It's predefined. Okay? So that's nice, but you might not know that it's there. So what did they do here? They took US arrests and trim 2%. So that's kind of weird because US arrests actually is a whole table of data, right? It's murders, assaults, urban population, and rape for all these 50 states, right? So what does it mean to take the mean? Well, fortunately, what it means is that it'll do each one of them. So it'll do the mean murder, the mean assault, the mean urban population, the mean rape. So you can put in a whole data table here, and then write mean, and might know what to do. Seems like it will know what to do. And don't forget we did the trim here, so that means we cut off the probably the extreme values. And I just tried to find out what trim meant, but can't do it that way. Okay, that's all.